plus T surrounding times T minus T surrounding times the area. Essentially what I'm doing is this is a to the power 4 minus b to the power 4. So that's a square plus b square times a square minus b square, which is split into a plus b times a minus b. We did this at the beginning of the semester, if you recall. Now we are going to say the following. All of these, we are going to call it as H radiation. It's almost like a radiative heat transfer coefficient. It's an approximation, but why not? Who's stopping us? So say, Q radiation is some H radiation times a T minus T surrounding, okay? Where H radiation is the following, is sigma epsilon T square T surrounding square T plus T surrounding. Take the absolute worst case scenario, okay, there is no cooling taking place at all. Okay, so absolute worst case, T is 300 degrees, T surrounding is 20 degrees, please convert them into Kelvin, okay, so into Kelvin, epsilon at the beginning of the problem was given as 0.2, so this is epsilon aluminum. Sigma is your good friend Stefan Boltzmann constant. Substitute everything and obtain H radiation. Last couple of minutes. H radiation, substitute, this becomes approximately around 4.06 watts per meter square Kelvin, and believe it or not, the units work out. The unit is actually watts per meter square Kelvin, which is why you can say that this is approximately like some radiative heat transfer coefficient. So that's one. Now calculate H bar from convection. This is the bulk heat transfer coefficient from convection. H bar by definition is given using the Nusselt number. H bar, L bar, Kf. So that H bar is NuL Kf by L. We have NuL given to us, okay, this is the bulk of the average Nusselt number, so substitute. Which ends up being around 36 watts, approximately 36 watts per meter square Kelvin. 4 times, 9 times what I had for H radiation. So which tells me that if I just do an order of magnitude, so this is called an order of magnitude approach. If you do an order of magnitude approach, you see that this creature is much higher than the heat transfer convection coefficient from radiation. So this does not do much for me in my life at all, and so I can actually neglect it without any much of a change in the problem. Okay, so H bar is an order of magnitude greater than H radiation. Okay. Alright, so we'll stop here. Monday, I'm going to solve 2 problems, one on convection, one on transient conduction. We will go a little beyond time. I appreciate your patience. If you have to leave, please feel free to leave. Okay? Thank you.